Okay, so let's start this question by reading the question. Figure 1 shows a block with a graduated side and dimensions 4 centimeters by 4 centimeters by 16 centimeters, just about to be lowered into a liquid contained in an overflow can. During an experiment with this setup, the following information was recorded. The block floated with 3/4 of it submerged. Initial reading of the balance is 0 grams and the final reading of the balance is 154 grams. Use this information to determine the density of the block for 7 marks and the density of the liquid for 2 marks. You've been asked to use the value of G as 10 meters per second squared and to give your answer to 1 decimal place. I have added this simulation here in order for you to be able to understand or to get a visual impression of what happens. So we immerse the object into this liquid, and definitely there is some water which is displaced and it goes into this can. It is caught in this can. Now let's see how we solve this question. We start this question by asking this simple question. How is density of a substance calculated? How do I get the mass and the volume of the solid? Because these are the two physical quantities that I need in order to calculate density. It is at this point that you should go back to the question trying to pick up any pieces of information or threads that the examiner has provided, because the examiners always provide pieces of information pointing to the concept that you must use. The first is that of displacement, because from this question you can see that there is the liquid which is displaced. So you think about the displacement method, and the other one is that of flotation, because you can see again from the question you've been told that that block floats. This question tests several physics concepts covered in different topics. The first is determination of volume of a solid by displacement method. This one was covered in measurement 1. The volume of displaced water is always equal to the volume of the solid immersed in it. It is important to emphasize here that the volume of the water displaced is equal to the volume of that part of the solid which is submerged or which is immersed. That is, that part of the solid which is below the liquid. In this case, the volume of the water displaced is equal to 3/4 of the volume of the solid. So the volume of the solid will be equal to the length, which is 4, the width, which is again 4, and that part of the solid which is submerged is 3/4 of this length. Since this length is 16 centimeters, then 3/4 of that will be 12 centimeters. 12 centimeters, because 4 goes into 16 4 times. 1/4 of it is 4 centimeters. So I have this being 4 centimeters, 4 centimeters, 4 centimeters, and the other one 4 centimeters. So 3/4 of it will be 12 centimeters. So the volume of the solid immersed is 192 centimeters cubed. So the volume of the water displaced is also equal to 192 centimeters cubed. Although this method is reserved for irregular solids, it can be used with regular shapes, because the concept is that one of displacement. The second concept being tested in this question is that of the law of flotation. Now, how do we know this? We observe that we've been told that the object floats. So you should observe that the block is floating. This means that the law of flotation must apply. And the law of flotation states that the weight of the object is equal to the weight of the water displaced. So, since we know the weight of the water, weight of water must be equal to weight of the solid, which is floating. This is the mathematical statement of the law of flotation. The weight of the water is 154 grams because we are told that when the setup is such that the solid has not yet been immersed, the reading of the balance is 0. That means it has been zeroed after putting on this container. So the scale was set to 0 with the container on it. So as soon as this water pours onto it, then the reading here becomes equal to the weight of that water. So weight being equal to mass times the value of the gravitational field strength, this will be 154 divided by 1,000. We get that to be kilograms. And then the value of G is 10 Newton per kilogram. This is usually referred to as the gravitational field strength. That is how strong the gravitational field is. And we get 1.54 newtons. This is the weight of this water. So it means that the weight of the water being equal to 1.54 newtons should be equal to the weight of the block, which I'm calling the solid. Now I can work backwards. Since I know W is equals to mg, I want to get the mass of the block. Since I know that its weight is 1.54, m is there, and g is 10, I would be able to see that the mass of this block is equals to 0.154 kilograms. And you find that it is the same as 154 grams. 154 grams. Now you're asking, why should we go through all this process instead of just taking this value? Remember, the law of flotation deals with weight. It doesn't deal with masses. It deals with one type of force, which is the weight of the liquid which is displaced. By the way, here I'm assuming this liquid is water, but it is actually not water. We've just been told that it is another liquid. So, but since we use water most of the time, if this solid was being immersed in the water, then the weight of the water will be equal to the weight of the solid. But because it is any other liquid, the same statement applies. Weight of liquid is equals to weight of the solid. So remember, you've got to deal with weights, which are types of forces, rather than masses, which are scalar quantities. That is why I have to convert the weight of the water into newtons, because it is a type of force, and then I equate it to the weight of the solid. By the way, when I say it is equal to the weight of the solid, the weight of the water displaced, this is the weight of the water displaced, by the way, is equal to a type of force we call the upthrust. Like that. Okay, having got the mass of the water, and we know the volume of the water displaced, we are going to use these values later on. What I want to get now is the volume of the object. Remember, this is volume of liquid displaced. This is equals to the volume of the liquid displaced. It is not equal to the volume of the block. Volume of block is equals to 4 by 4 by 16, because the length or the height of that block is 16. This what gives us 256 centimeters cubed. Yes, 256 centimeters cubed. Therefore, the density of the solid or the density of the block is equals to the mass of the block divided by its volume. Since I know the mass of the block, which is this one here, 154 grams, I divide that by 256 centimeters cubed. This should give me 0.60 grams per centimeters cubed. And in 1 decimal to 1 decimal point, I get 0.6 grams per centimeters cubed. That will be the density of the block, or the density of the material which makes up the block. So that is part A. In part B, I'm asked to determine the density of the liquid. So the density of the liquid is equal to mass of the liquid over the volume of the liquid. The mass of the liquid directly is 154 grams, so there is no problem with that. Divide by the volume of the liquid, and the volume of the liquid is definitely equal to the volume of the block submerged, or the volume of the block below the surface of the liquid, and we had already obtained it as 192 centimeters cubed. And that gives us 0.8, again to 1 decimal point, grams per centimeters cubed. And that is how we would work out that question.